All right, we are live. What's up, guys? This is Dem Keys, and today I'm going to be doing another study stream. Though, before, like literally seconds before I started the stream, I was wondering if I should do some VR chat world exploration today. But the thing is, right now I've already got this whole setup going. So I don't know how well that would work out. Because, I mean, I did a study stream yesterday. I still want to carry on doing the study stream. I only have about like, unfortunately, I couldn't start early. I should have started early. I actually could have started like um, an hour ago, but like, it is what it is. Um, but I'm gonna try my best to stream for at least 2.5 hours today. Um, we're slowly getting back into the swing of things. And today I'm gonna carry on doing what I was learning yesterday, which is doing socket programming or network programming in Python, and hopefully we're gonna learn something. I was supposed to carry on doing research yesterday after ending the stream, or well, I was supposed to carry on. Like yesterday, I had found out that yeah, there's a couple of other uh, packages that I need to do research on, a couple of other modules I need to do research on. I looked into them. The threading module, I don't think I need to dive too deep into it because it seems a little too low level, a little more low level than what I need to go to. I don't know if I said that right. It seems a little too low level, and while I don't mind going that low, it seems unnecessary for what I'm trying to accomplish, because what I'm trying to accomplish is just multi-threading, any kind of multi-threading. And I don't necessarily need like bare bones threading in order to accomplish that. I feel like I can use some kind of like async framework, which Python does provide. One they definitely provide is async IO, but from what I understand, there's like one or two others as well. Um, each one has its own pros and cons. I'm gonna be diving into async IO stuff as well once I'm done reading this. You know, I'm wondering if I should bring. Actually, no, I can't do that. I was wondering if I should bring up the browser. You know what I could do? I could try doing something where I bring up the browser in a small area on the screen. I feel like that would be kind of interesting. I've never done that before. I feel like that would be kind of interesting. It'll be silly as this may sound. It'll be kind of like my React Andy, if that makes sense. You know what? I'm gonna try something right now. I'm gonna switch to the BRB screen real quick, and then I'm gonna try something in my main. Man, I like this transition thing that we are able to do. In OBS Studio mode. Okay. Um, which, by the way, also another thing that I plan on doing networking with, because like OBS exposes a WebSocket server, or well, I mean, it has a WebSocket server running that exposes functionality uh, of OBS. So you can like send requests to that server. It's a local server. It's running locally, like when you run OBS. So you can like send and receive messages to and from that server to do various things. One example would be I haven't tried this practically, but like it would be kind of dumb if that didn't exist. One example would be being able to switch scenes, for example. Okay, anyways, so now I want to try something out. What I'm gonna do is I have a window capture here. I have this. Am I able to capture the browser? How do I capture the browser? Like, okay, let's open up the browser here. And let's move here and there. The browser seems to be seen. Okay, let's bring that up. And now let's reduce the size of this. I don't know how small is too small. Okay, but this will make it so I'm able to here's what I could do. I don't know how well this is gonna work. Oh no, I forgot. Capturing the browser, it has like horrible performance. Okay, so I'm just gonna try something here. Here, let's just Python socket how to. Okay. We have this here. Uh Give me a second. I just need to Google something real quick on another system. This is more dead air than I intended, but just bear with me for a second. Okay, I'm just setting some stuff up. Just give me a second. Okay. All right. Okay, cool. So I'm gonna bring this up here. Okay, I wonder what this is gonna look like. All right, so this is not the best, but it is what it is. Let's see. You know what? Let's see how this looks. I'll try this out for a little bit. I don't really like seeing this in light mode, but you know, just bear with me for a bit. Um okay, so we can now transition and give me a few seconds. Okay, there it is. You know what? I'm gonna transition back because I feel like this could use a bit of cropping. Uh, so small right now, dude. I'm hold hold on, dude. This is so small. Can I like pop this out? I don't think I can pop this out. Oh, maybe I can pop this out. Does that work? Yeah, okay. I can temporarily pop this out. And now edit this. Okay, that should be good. And now I can pop it back there. Where was that doc? I think it was stats. All right, great. How do I put it back in here? Oh, there it is. Okay. Right, so we are gonna give this a try. Okay. So I'm reading the stuff off here. Though this is kind of inconvenient if I'm being honest, because let me like full screen my own stream and see what that looks like. Yeah, this is a little bit inconvenient because I don't need to do this. I have another screen on which I can read the stuff very easily. And it yeah, you know what, this is kind of inconvenient. Though I mean it makes it so things there is like at least a little bit for you guys to see. Like you can read what I'm currently reading, but it's also kind of inconvenient because I'm right now, like, you guys can see the VS Code window, but I'm not in the VS Code window right now. So like I have to switch to the VS Code window to actually do something there, which makes this kind of, you know, inconvenient. Um, yeah, okay, no. So I'm gonna minimize this. I'm also gonna, wait, let me switch back to my BRB screen. So I'm gonna minimize this. I'm also gonna hide this. Though it's good to know that that works, because like I'm definitely going to be able to use that for something else. When I start doing neural network stuff, um, I'm going to bring up the neural network uh, image, the neural network's diagram in an image. I can like bring that up on screen. There's this awesome website. I forgot the name of the person who made it. I'm gonna have to look again. Um, but this person made a website. Oh, let me transition back. Yeah. This person made a website that lets you visualize neural networks. Not just one type. There's 3 different types of neural networks that you can visualize, and like each has like its own different architecture and its own, because it's a different architecture. So each has like its own type of diagram, its own way of representation. And this is actually really helpful because it makes it so people who are creating neural networks using, for example, PyTorch, or even if they're making a neural network from scratch, they don't have to draw the entire diagram themselves, because drawing the diagram, it takes some time, which, to be honest, it wastes some time, like having to draw the fucking neural network each time. Imagine you make some changes to the thing. Now you have to go in and change that diagram. This tool that this person made, it makes it so you can generate the thing procedurally, just by changing, or well, you can generate it procedurally through parameters that you specify there. So it's helpful. It really helps. And I've been doing research on neural networks. Soon we're going to be getting into neural network stuff as well. It's just sometimes I get a little. Oh, we seem to be buffering. What is going on? We seem to be buffering. Okay, we are fine now. Great. So yeah, it's just sometimes I get a little sidetracked. In a way, it's a good thing, but it also ends up being a bad thing because I get sidetracked from stuff that I'm supposed to be working on. For the past week, what I was sidetracked with was GPU programming and GPU architecture, which kind of, it comes back to, being able to do ML, and more specifically neural network stuff. And I'm going to be using that knowledge in the future, but the point still stands that, like, me getting distracted for that 1 week, it ended up taking time away from this other stuff that I was supposed to be working on. Why was I talking about this? Oh yeah, okay. So I have been doing research on neural network. Dude, neural networks are a really interesting subject. They're a really interesting topic. Um, I still have like a lot to learn about them. Even the simplest neural network, I want to construct the simplest neural network, maybe from scratch if I'm able to go about it. If not, then I'm perfectly fine with using a library like PyTorch, or if scikit-learn provides you with the functionality for it, then even with scikit-learn, I don't mind. But yeah, I wanna make, at the very least, the most basic neural network, which is a feed-forward neural network. You have an input layer, a couple of hidden layers, and an output layer. And I just want to study how the data goes through it, and how it performs. But there's just like that. There's a bunch of other ML related things that I need to do research on, that I have been doing research on, that I need to do practical stuff on. Dude, see, I started this stream 20 minutes ago and I've just been chatting. I've just been talking. I should really start starting these streams in just chatting, because I just end up, well, chatting. You know what? Okay. Why the hell not? Let's go into just chatting. Though, okay, no, I should be studying. To be fair, though, I could be doing, I could be studying in just chatting. I could do that. Yeah, let's give it a try. We're gonna switch to just chatting. And now we're gonna carry on studying. I just got a gift sub to someone. Okay, cool. Thank you. Well, I didn't get it. Well, I mean, I didn't get a gift sub on my channel. I got a gift sub on somebody else's channel. So somebody gifted me a sub. Anyways, dude, let's carry on. Let's carry on doing this. Okay, so yesterday we were in this portion, I believe. Okay, so a couple things to notice. We used socket.getHostName so that the socket would be visible to the outside world. If we had used s.bind localhost or s.bind so-and-so, we would still have a server socket, but one that was only visible within the same machine. S.bind without any address specifies that the socket is reachable by any address the machine happens to have. Alright. A second thing to note, yeah, okay, that's the port number thing, great. Finally, the argument to listen tells the socket library that we wanted to queue up as many as 5 connect requests. The normal max before refusing outside connections. I didn't know that up to 5 requests was the normal max. I thought it might be more. If the rest of the code is written properly, that should be plenty. Now that we have a server socket... Wait, that was a server? Dude, shit, you know what? Okay, for the sake of being able to do things on this system, I'll set up the server here, and I'll set up the client on my other system, and then I'll communicate with it from... I'll communicate between the two. Okay, so let's set up the socket. So that's s.socket or sock.socket, and then it's sock. So it's an inet. It's inet address family. The socket type should be stream. And I don't think I need to specify anything else, right? Okay. And then the address, I need to get the IP address. Wait. It's the IP address of this machine. It's the IP address of this machine. I forgot what the IP address of this machine was. I don't want to open command prompt right now because I don't know if it's going to cause things to freeze. Well, okay, I could just bind it here. So let's do 9010 port number, and then s.connect. Why are we connecting first and then binding? Oh, what I'm looking at up here. Roughly speaking, when you click on so and so, your browser did. Oh, that was client code I was looking at. Okay. All right, great. So something I'm still kind of confused about is whether the address can just be the computer's name. I thought it needed the IP address. But anyways, so s.bind, and then this needs the address to bind to. And then s.listen 5. Is this going to be blocking? I'm not sure. Okay, a couple of things to notice here. So and so, so and so, so. Fine, that's great. Finally, we have listen. Okay, now that we have a server socket listening on port 50, no, on port 80, which that was in their code, minus 9010, we can enter the main loop of the web server. While true, client socket, address, accept connections from the outside. Okay, now do something with the client socket, ct.run. Oh, this is assuming this is a threaded server. In this case, we'll pretend that this is a threaded server. So in my case, we are not going to pretend that this is a threaded server because this is not. So we'll still do the same. Let's call it CSOC, just to keep the name short. Or, well, okay, so I'm calling the server socket S. I can call the client socket C. And then we have C underscore address. So that's a tuple. Here it'll be S dot. Okay, hold on, dude. Server sock. Fine. So let's give it proper names then, I guess. Server sock dot accept, and then once it's done something, I can print out. Oh, hold on. If client sock what are the options here? Do we have like an is connected kind of thing? Oh wait, what happens if I do a while loop in a cell? I didn't think about that. Yeah, what happens if I do a while loop in a cell? Let me just look that up before I end up crashing the Jupyter Python while. Let's just Google that real quick. Using while loops. Okay. Actually, you know what? Let's test this out. So I equals 0 while I less than what, 10, print I minus minus. Oh, I don't remember if that's a thing in Python. Is I plus plus a thing? No. Okay. I minus equals 1. Great. Now let's see if this works. Oh, hold on. What is going on here? Oh, it's because it's oh shit, I forgot. Yeah, it's doing the other server socket stuff. I forgot that other code was there. Shit. Okay, give me a few seconds. You guys can't see, but like a thing just popped up here, and now this thing is running, and oh, wait a minute. Oh, this is blocking, isn't it? I think it's blocking. I think it's blocking. Yeah, I think it's blocking. You know what? You know what I'm gonna do? I'm gonna... Wait, why did it execute this thing then? If it's blocked, why did it run? Why did it actually get to this point in the code if the listen is still going on? Okay, so I'm real quick, I'm gonna write some code here. Socket stream s1 dot connect. Just give me a second. Oh shit, I need the IP address of this to connect there. Give me a second. Oh, well, anyways, there's an ad going on right now. Okay, what are we looking at here? Oh shit, what is that? Just let me get up and look at it. Okay, I got it. Okay, so we are good there, and then the port number is supposed to be 9010. So that's where we're supposed to be trying to connect. Let's run this. This does not seem to be going well. So what I'm gonna do is interrupt this before the entire thing just hangs. Um, oh no. All right, so we are just gonna be waiting here while this does its thing. Seems to be... I'm wondering if it's because this is a blocking operation. It didn't mention anything about blocking though. Which one was it? استمع إلى الموسيقى بدون إعلانات وبالإنترنت وفي الخلفية. جرب يوتيوب ميوزك بريميوم مجانا. We have received, send. Okay. Listen. Enable a server to accept connections. If backlog isn't specified, it must be at least 0. Uh, spec Wait, it specifies the number of unaccepted connections that a system will allow before refusing new connections. If not specified, a default reasonable value is chosen. I think this whole thing is just frozen at this point. So we are going to switch to the BRB screen. I'm going to close VS Code. Am I able to save this? Yeah, no, I think I'm going to have to close the whole thing. So I'm going to close the whole thing and reopen it. Just give me a second. I'm opening up or trying to open up Task Manager so I can close VS Code. So I watched the Microsoft build event. Well, I watched part of it, and I don't know if I'll watch the rest of it or not. Oh wow, we are at like almost full capacity in terms of RAM. Okay, so it's kind of exciting seeing the various AI features that they are implementing. I'm a big fan of like machine learning stuff, so it's been really exciting for me to see a lot of different platforms implementing these various ML and just in general AI related things. Oh, oh wow, holy shit. I think I caused some sort of infinite loop that for some reason is causing VS Code to just eat up so much RAM. For some reason, VS Code is using up 2.6 GB of RAM. So that kind of explains why I was suddenly getting bad performance. But yeah, it's been exciting seeing all of these different things. Um, I think 2 weeks back there was the Google I/O event, I think it's called, and even there they had showcased various ML, AI and ML related features that they were introducing. This was like a day after they had removed the waitlist for Google Bard, and Google Bard was exciting news for me because like where I live, ChatGPT is unfortunately not available for whatever reason. It seems to be limited, which at this point it's kind of confusing for me. I wonder if it's just the fact that if it's just the fact that massive companies like Google and Microsoft, they are like trusted companies and they have connections in like all over the world, so like they are not necessarily being blocked, but for some reason ChatGPT or OpenAI in general was being blocked from the beginning. I don't know if it was like a data collection, data privacy kind of thing, and like maybe these countries think that with Google they don't have that issue. So we have just like open access to Bard. But for some reason we still don't have open access to ChatGPT. Like regardless, even if you plan on paying, it just won't let you. Like you create an account and it's gonna say OpenAI services are not available in your country, which it was kind of a bummer. So we didn't really get to look too much into ChatGPT, and we had to resort to other methods, like for example communicating with a bot on Twitter. There's a ChatGPT bot. There's probably a couple, but like the one that I was using is just called ChatGPT bot. Like you can add that account on Twitter and then add whatever your question is, and it'll take however long it takes to respond depending on what its backlog looks like, because like there's a couple of other people trying to use it as well. So it'll take however long it takes to respond, but you will get a response eventually, basically from ChatGPT. So this is a bot that's going to relay your question to ChatGPT and then get the response back and then give it back to you. So I'd been using that for a while. It's a very, very slow method, and how long it can take for you to get a response will really depend on how busy that bot is, because you're not the only one using the bot. There's a couple of other, well, there's a bunch of other people using that same bot. So it was a very slow method. Eventually, I started looking into open source language models. Um, and that was exciting to look at as well. I found, so this was interesting. I did mention this before. Um, there's a framework called LangChain. Um, I still need to dive deep into LangChain as well, because it seems like a very, very useful framework to get into. Um, Not just for ML stuff, but for other stuff as well. That is why I kind of want to learn how to use it and like see how I can leverage its power to create something useful. I'm definitely going to be using it for ML stuff as well later on, but like first, just for practice, for practice purposes, I kind of want to experiment and make a couple of small things with it. I'm probably going to do that on stream as well, so that should be fun. Anyways, I was looking at the LangChain documentation because I was trying to learn about LangChain, and LangChain, they have a help assistant, which is, it's a bot that interacts with ChatGPT to a certain extent. It interacts with ChatGPT. When I found this out, I actually kind of had a doubt, because like I first found out about LangChain through ChatGPT related topics, because people were making agents and various other things using LangChain. So that's how I kind of found out about LangChain. And you know what? Okay, you guys don't need to carry on seeing this BRB screen. We can transition. Okay. We're gonna need to wait for a bit because, well, my system is not doing too well. Oh, in the meantime, I should probably comment out these two lines and save the cell. Oh, also, I'm not sure what's going on here, because like this thing hasn't loaded. I'm wondering if I should give it some time, or
And now you're ready to fall asleep. Keep your ASMR video playing, even with your screen off.
okay. Anyways,
YouTube Premium on us.
so I found out that it's basically powered by ChatGPT, Like that bot is using the help of ChatGPT. I'm assuming it was making API calls, and so that became like a little cheating method for me to use ChatGPT. Um, it worked in uh, a bunch of cases. Like I was doing research on a couple of ML related things, so this worked for me specifically, like for specifically that situation. But it did seem to have sort of a limit on what topics it was okay with discussing. In the sense, if you went too off topic from what it's meant to teach you, which is the LangChain and AI and ML related stuff. If you started to go too off topic from it, if what you were asking it wasn't related to AI and ML stuff, it probably wouldn't respond very well to you. It would just say it doesn't know the answer or whatever. In fact, even when I would ask it ML related stuff, I would get a response, but at the beginning, first thing it would say is, "Sorry, I cannot find any information about this." And then below that, it would give the entire information, because that right there is then ChatGPT replying to me. So that's how I found like a little loophole there, and I started using it to do my research. And then later on, when I found out that other models were coming out, one of them being Stable Vicuna, that was an open source model, I believe made by Hugging Face. I don't remember exactly, but I was excited for that. Um, Llama was another one that I was excited for. I haven't had a chance to interact with it yet. There was another one, I think it was called Mosaic. I don't remember. I think it was called Mosaic. I tested that out for a little bit as well. That was okay as well. Both of these, they had some latency, some latency to them. Because like it's an open source model, it's running on the cloud. There's going to be some limits if you are trying to access this resource for free. Give me a second. Let me activate the environment. All right, we are good there. And now let's run this while loop again. Wait, so it started at 0, and then I made sure it's less than -10. As long as I is less than -10, it would print out. It would first print and then it would decrement, right? So it would print out then 0, then decrement. So now it's -1. Then it'll print out -1, -2, -3, -4, -5, until it hits -8. Okay. Oh, it's an infinite. I just realized my mistake. It's an infinite loop. It is an infinite loop. Dude, okay. That was dumb. Yes, yes, let's just restart the whole thing. This I made an infinite loop. So what I should be doing here is, while I is greater than -1. So now if I run this, somehow I don't know where my mind was. I just completely missed that I was creating an infinite loop. Right, so this executed pretty quick. So now I know. Okay, what does accept return? What does accept return? It returns a tuple, which is the socket and the return address. It doesn't return. Okay, how do I catch, like, if we get a request? Because I need to be able to. I need to be able to receive data, because like I need a trigger where I can stop the while loop, because otherwise it's just going to keep going, which I don't want. Dot accept. What if it accepts without, wait, is accept gonna block? Let me look up accept. Okay. Socket dot accept. There it is. Um, this, I don't know if it mentions. Is there a timeout for this? Okay, accept a connection. The socket must be bound to an address and listening for connections. The return value is a pair, which is a connection and address, where, yeah, okay, that's fine. And the socket is, wait, con is a new socket. Okay, yeah. So it's a socket that is usable to send and receive data on the connection. Okay, what if I try to print out the address, client address? What if I do this? Let me just have that the other kernel prepared. Uh, connect. Okay. I don't know if I'm doing this right. Wait, so I've created the socket. Um, if it's a TCP socket, okay, okay, that's fine. Uh, so we're gonna do this. We're gonna let it run. I think it's just running because it's waiting. There it is. There it is, dude. Okay, let's try it again and again and again. There it is. Holy shit, dude. Let's go. Okay, so we have established a connection. I feel like each time I get back into this, I need to read up on some of the basics, because like with a server socket, you need to bind the socket to a specific address and port. With a client socket, you don't need to bind, you just need to connect to it. And this is like if you're talking about a connection oriented protocol, um, which is like TCP. But if you're talking about UDP, which is a connection-less protocol, I don't think you need to bind in that. Um, I think with UDP, you just need to listen. You just need to listen on the port uh, at your specific address, and then any other machine on the network can just spit packets at you, UDP packets specifically, and like whatever gets accepted gets accepted. The only risk there is it's a connectionless protocol, so it's not guaranteed that every single packet that you uh, that somebody else throws at you, you're going to receive it. There's a very good chance that it can just get lost somewhere for whatever reason. So, though specifically for my purpose, I think I can deal with some packet loss. That should be fine. I guess that would depend though, because like I'm planning on sending tracking data. Tracking data is fine if a few packets get lost here and there. It's probably just going to lead to some, little glitches here and there. That's not going to be so bad. It's kind of like watching a Twitch stream and like a few frames got lost. It's kind of going to be like that. It's not going to be that big of a deal. But if I'm interacting, if I'm, for example, if I've created a remote control kind of application that is going to send signals to my main VTubing application, I kind of want those messages to get through. Um, though, that's not necessary either. I could just make my design such that it doesn't need to be a connection oriented protocol. Like I don't absolutely need every single message to get through. Even if some messages sometimes drop, it shouldn't be that big of a deal. So, for example, if I wanted to change a scene from by sending a message from another system on the click of a button, I'll then click that button and it's going to send the message, and then over here it's going to change the scene, right? But let's say I click the message or I click the button and the message. This is getting a little loud. I don't know if this is coming through on stream. Okay, what was I saying? Yeah, let's say I click the button and the message gets sent, but it doesn't get received here for whatever reason. Um, that shouldn't be that big of a deal because I should just be able to click on that button again, so it'll send the message again. The only time I feel like I would need a connection-oriented protocol here would be if I was doing something that required synchronization, like strict synchronization. So like if I've clicked, if I've toggled a switch in the remote control application that happens to be running on another system, I want to make sure I'm synced with the state. So like if I've turned on a switch there, but like that switch is meant to be turning on something over here on this machine, then this machine should be able to send that state. It should be able to synchronize that state with that other app, which is on another machine. But I feel like I can avoid that kind of design. I don't absolutely need that kind of design. Anyways, I don't know if what I'm saying is making a whole lot of sense. It makes sense to me, but like, I don't know if it's making a whole lot of sense to anyone who hears this. Anyways, so we've accepted a connection. Um, right. So how do I go about this? It's supposed to accept the connection and then do. Actually, let me go back because it did mention that with client sockets, it's supposed to accept the connection, do something, either send data or receive data, and then destroy the socket, and then create it again. Um, that's not usually how you do it in on the C# side. I don't know if that's like a common practice, but like at least from what I've seen on the C# side, you don't necessarily destroy the socket. You keep that same socket alive for as long as you need. Though it's worth mentioning that I'm doing this in Python. Python is running on C. So like whatever I'm doing here, there's a good chance that like it's handled very differently in the back end. So maybe that might be one of the reasons why they need why this is a practice where you destroy the socket after doing one thing with it. Okay. All right. There's actually three general ways. I'm reading the documentation. There's actually three general ways in which this loop could work. Dispatching a thread to handle client socket, create a new process to handle client socket, or restructure the app to use non-blocking sockets. That's the approach that I want to go with, using non-blocking sockets. Just a second. Okay, back to what I was doing. So I kind of want to go for the third option. I don't want to create a separate process to handle the client socket, though I think in a way that would be one way to make it multi-threaded. There's also, well, dispatching a thread to handle the client socket. That would be another way. I, if I'm being honest, I want to go the lazy route. To be fair, not really lazy. It's going to make it so it's not so much of a headache for me. I want to see if I can do this using async stuff. So one of those things where it kind of becomes like it's like its own separate task, and it'll finish whenever it finishes on a separate thread, and then later on I can just check if the operation is done, and I can read the data. Um, oh wait, the sentence wasn't over. Let's reread this again. There's actually three general ways in which this loop could work. Dispatching a thread to handle client socket, create a new process to handle client socket, or restructure the app to use blocking sockets and multiplex between our server socket and any client sockets using select. More about that later. The important thing to understand now is that this is this is all a server socket does. It doesn't send. That's interesting. Oh, you know what? That makes sense, doesn't it? Because like I have the client socket here. What I have is an endpoint, like my endpoint. I'm using this to communicate with that client. So like I could do client socket dot send from here, and I could then receive it on that end. I don't know if it's going to accept the data. You know what? Let's give it a try. Let's see. It's not blocking, so I don't know if it's gonna receive instantly. Um, let's give it a buffer size of, okay, let's do b equals this, buffer size of 3. I think it's an int. It's an int. I don't know what flags I'm supposed to give it. Okay. Uh, print b. Okay. So here's what I'm gonna do. I'm gonna send some data to the client socket. Client.send. This takes a data buffer. I'm assuming it takes bytes. So I'm going to send ABC, flags 0. Let's just do what R res, and let me get this. Great. Oh, I also, wait, I noticed something, or well, something just occurred to me. Something happened. Let's do this, okay? Let me get rid of this. Let me also get rid of the other code here. So that is attempting to connect there. You guys can't see what I'm talking about. This right here, okay. So this is currently blocking. This is currently blocking because otherwise it would have printed something happened. Except is currently blocking, and it's only gonna, so that's where the loop becomes like, I don't necessarily need to break it. I can keep running this, and each time you see something happen popping up here, it's because I've I've tried to connect to it from the other system. Okay, so now I can interrupt this. Now I need to come up with a good I need to come up with a way to be able to break the loop. So right now I wanna establish communication between the two. Oh, you know what I could do? I could send from the other system and receive the data here. So we create the socket. Does receives bytes. That's the result. The buffer size is 3, flag 0, and then it prints out the result. So we get this loop going. Okay, and here I want to send data instead of receiving it. So let's do send. We want to send a byte buffer of ABC. And then we'll just print this out. Okay, ABC received. And again, and again, and again, and again. All right. Oh, can I send only A? Yes, I can. So here's what I'm going to do. Okay, what happens if I try to restart this? No, that's not going to work. It's blocking, so it's kind of just stuck there. So I'm going to restart this. I'm going to, in the meantime, while it's restarting, I can rewrite my code here. Okay. If res equals q break. All right. All right, so let's run this. That's running. Great. So that sends A, then we can send B, then we can send C, then we send Q, and that exits the loop. Holy shit. We just established communication between the two systems. This is done using Python. So now I just need to refresh my knowledge of socket stuff in on the C# side. More specifically, I need to look into doing socket stuff using the tap model. So I can do async socket stuff. Okay, cool. So let's carry on reading. Um, the important thing to understand is that let me restart. The important thing to understand now is this. This is all a server socket does. It doesn't send any data, it doesn't receive any data, it just produces client sockets. So yeah, okay, that's where I'd like kind of gotten distracted and suddenly started focusing on this thing. So yeah, the client socket that's returned here is basically, conceptually, you can think of it as a as an endpoint like communication, an endpoint for your communication between this machine and the other machine on that specific port. It's also interesting that like I believe I have to destroy the socket. I don't think I'm actually destroying the socket here. Am I? I should be closing the connection, right? I think I should be closing the connection. I'm not sure. Let me just run that again. Um, let's do A. Let's do A again. Let's do Q. Okay. Okay, so I don't know if it's like implicitly handling the releasing of resources, but like um, I keep comparing this to the C sharp side because like I have to there's certain things I have to keep in mind with each one. Though I mean they're not all that different because like even on that end, because like here we are establishing a connection. We called bind and then we started listening and stuff like that. Um, in that case, it this here in the case of TCP, we had to bind first, um, and then we store the socket and all of that. I think the storing the socket is where it becomes like a connection oriented uh, communication. Because like with UDP, you wouldn't need to do any of this. With UDP, you could just do server socket dot send to, so it just sends to the IP address. You can then do receive from, so it receives from an IP address. Okay, so where were we? Each client socket is created in response to some other client socket doing a connect to the host and port we are bound to. Okay, that's a good way to visualize it. I'm glad that they mentioned that because like that helps me visualize it as well. As soon as we've created that client socket, we go back to listening for more connections. Oh, that's interesting. The two clients are free to chat it up. They are using some dynamically allocated port, which will be recycled when the conversation ends. Okay, cool. Um, I feel like I'm gonna need to read up more on this. Maybe somebody must have written um, their own guide on networking with Python, socket programming with Python. IPC. If you need fast IPC between two processes on one machine, you should look into pipes or shared memory. If you decide to use AF iNet sockets, bind the server Bind the server socket to local host. Makes sense. On most platforms, this will take a shortcut around a couple of layers of network code and be quite a bit faster. I actually I actually didn't know that. That is definitely good to know because I'm gonna need to do IPC on the same machine as well as between two machines. Because like I'm gonna have a Python script capturing that's capturing, body tracking data, motion tracking data, tracking data in general. It's gonna be capturing that data. Um, but then that data has to be sent to another. Actually, I don't think that needs to be sent on the same machine. I think that script is also going to be communicating across the network. So it's going to be communicating with another machine, which is my main streaming machine, where the VTubing app is. Um, Dude, at some point, I also need to write the networking code for the VTubing app because I need to set it up so that there's like an event based thing, not event based necessarily, but it's more like I okay, so I have to think about how I want to go about doing this. One way that I can go about it is I can treat it as a server and a client. So the VTubing app will be the socket server, and the client is then gonna connect to it and send messages, and the server is gonna then react accordingly. The server doesn't ever have to send anything back. Um, so I could do like a JSON kind of thing. I can create my own message format, or I can use a pre-made message format. Actually, I should do research on that as well. If there's like a pre-made message format that I can use, I can then just import that into Python and populate that. I mean, I can create my own class and like just serialize that to JSON. That's not a problem. I can then create the necessary class in C sharp on the C sharp side as well. It's just that I'll have to sit down and I have to think of a message format that's more unified, that works for everything that I'm planning to do in terms of communication. Because there's different types of communication that I'm planning to do. One is going to be, for example, sending tracking data. That's going to be different type of data than for example, if I was trying to send a message to, I don't know, change a color on the avatar, like these two messages they're going to be very different. They serve different purposes. They're for different purposes, but you would need to, yeah, they serve different purposes, but you would need to. I lost my train of thought, dude. Each of those messages serves different purposes, but I need to be able to present it in one unified format that works for basically any kind of message that I'm trying to send. It shouldn't be that hard because, like, considering this is on, my own machines, I feel like I can be a little bit wasteful in terms of resources, especially since this is not like communicating with the internet, it's communicating across the network. So I don't think it's going to be that bad. Okay. Um, Oh yeah, I was supposed to read up on multi-process. Wait, what happened? Why did this scroll all the way up? Yeah, I was supposed to read up on the multiprocessing. Oh, give me a second. Okay. Yeah, I was supposed to read up on the multiprocessing thing. Oh, now I remember why I didn't read up on it, because it's process-based parallelism, while I wanted to do thread-based, or, well, actually async, so task-based, not even thread-based. I want some system to handle the threading, the multi-threading capability for me, because I don't want to be stuck having to fight with threading code. That's the only way that I can do the higher level stuff without trying to implement every fucking thing myself. Dude, it's becoming kind of hard to talk. Give me a second while I take a sip of my energy drink and drink some water and all of that good stuff. You guys do the same if you need to. All right, let's get back to it. I'm pretty sure the music has stopped at this point. Yeah, I have no idea at what point the music stopped, but it just occurred to me that the music must have stopped. Oh well, it is what it is. Speaking of music, shout out to Ghost Data. Go check them out on YouTube and whatever other platform they're on. Okay, so let's carry on reading. Using a socket. The first thing to note is that the web browser's client socket and the web server's client socket are identical beasts. That is, this is a peer-to-peer conversation. Or to put it another way, as the designer, you will have to decide what the rules of etiquette are for a conversation. Normally, the connecting socket starts the conversation by sending in a request or perhaps a sign-on. The connecting socket, so that's going to be the client. But that's a design decision. It's not a rule of sockets. That makes sense, yeah? Because the server could also start the conversation whenever the client connects. Now there are two sets of verbs to use for communication. You can use send and receive, or you can transform your client socket into a file-like beast and use read and write. Okay. Wait, I forgot about read and write. Yeah, shit, I forgot about read and write because like I haven't been doing a whole lot of TCP based stuff. Um, I'd mostly been doing UDP based stuff. In what little practice I did, I'd mostly been doing UDP stuff. I touched TCP a little bit, but like not for too long. And I remember there being some file reading and writing options there. Okay, let's look into this. Client socket dot. Is there a read? No, there's no read here. Oh, maybe there's a different way to. What about here? Yeah, okay, maybe there's a different way to go about it. Let me carry on reading. The latter is the way Java presents its sockets. I'm not going to talk about it here, except to warn you that you need to use flush on sockets. These are buffered files, and a common mistake is to write something and then read for a reply. Without a flush in there, you may wait forever for the reply because the request may still be in your output buffer. Oh, so if you don't flush, it's not gonna write. Is flush here? Oh, I'm not sure if they're still talking about. Python, because like this doesn't connect. This doesn't contain a flush thing. Maybe they're talking about Java. I'm not sure. Okay. Now we come to the major stumbling blocks of sockets. Send and receive operate on the network buffers. They do not necessarily handle all the bytes you hand them. Oh, that's interesting. Or expect from them, because their major focus is handling the network buffers. In general, they return when the associated network buffers have been filled or emptied. Wait, what? Then they tell you how many bytes they handled. It is your responsibility to call them again until your message has been completely dealt with. That's that's interesting. I'm gonna try and send a massive uh, a massive amount of data. Um, Wait, no, that's a list. How do I? Oh, okay. So I was gonna try and use list comprehension, something like b equals what? B a for x in range 4096. The problem is this is not going to be... How's that going to be a byte? That's not going to be a byte to begin with. It's going to be a list. So in this case, what is it receiving? It's receiving a byte buffer. So does it accept lists? Let's call this some data. Oh, I should be creating this on the other system. Say some data equals b a for x in range 4096. Okay, and then now I want to try and send some data. Okay, so connect also seems to just stop there. Okay, this is gonna print... Oh, it timed out. I'm guessing it timed out. No, it didn't time out. A bytes-like object is required, not a list. So how do I go about doing that? A bytes-like object. Hold on, let me try something here. So we have... Actually, let's also get rid of these. So let's say we have something, and that is a byte A, right? We print something. That's the result. Now let's say we want to do something plus equals B A. Okay. Oh wait, I forgot. This is not a single byte. This is a bytes-like object. So that's why I'm able to do something like this. Okay. Okay, that's fine. So that's okay. I can just write I'll just write a for loop. For I in range 4096, some data plus equals b a, and then I'm gonna try and send that. Okay, so I'm not seeing any errors so far, which is good. Great, so let's test this out. Oh wow. An invalid argument was supplied. How so? That's weird. Okay, let's try it again. Again, invalid argument supplied. When error, wait. Oh, I'm trying to receive from there. I should probably send. Okay, let's try it now. No, it's not. Okay, it's saying an OS error. Okay. Let's look that up. When error 10022. Oh, I didn't uncomment this code. Yeah, that's the server, the socket hasn't been bound. That was the problem. Okay, so that problem is fixed. Now let's try to send data. Okay, it received. It only received 3. Great. Okay, so let's send Q to stop it. Okay, let's do that, and some data. Okay, so let's see how much data this is able to receive, because I'm sending 4096. Next I'm going to send 8192. So we start this up and then we try to send the data from there. So it's receiving 4096. Let's do 8192. What comes after this? We have 4, 18, 8, so 2, so 4, 8, 2, 16. 16,282. No. Yeah. No? 16,382. $16,382. Yep. So we're gonna go for that next. Alright, great, cool. So let me just 8192. Send. Wait, what just happened? Oh, it stopped. Yep, that's my fault. Let's comment this and send this. Okay. Okay. So it seems to stop at 7,300 bytes. Okay. Let's. Okay, yeah. Let's quit this. Oh, you know what? Let's test it out right now. We can change this. We can do 7,300 or 7,299. What is that receiving? Okay, cool. We can do 7,301. Oh, that's interesting. In that situation, it only received that much. Why did it only receive that much? I'm actually very curious about that. Okay, what if I try to do 8,000? Okay, I need to be able to see these results. Okay, 8,000, 8,000, 8,000, 8,000. Okay, so I remember doing some research on this a while back because I was curious as to how much data I can send in one request. And a lot of people were recommending not crossing 4096. So like if you end up in a situation where you are crossing that much data, then like maybe break it up into chunks. I need to look into how I can send more than that much. 4096 is basically 4 KB. 4096 bytes, that's 4096 bytes, that's 4 KB. And here it seems like 7.3 KB or 8 KB is the max. I mean, it's not like I'm going to be sending more than that data anyways. In one request, I could very easily break it up into multiple requests. That's not an issue. Hey Jair, welcome to the stream. Hello. You're from Mexico. Your English is not very good. That's perfectly fine. As long as you're trying, that's what matters. Good on you for trying to learn English and practicing it. What am I doing? I am doing some Python programming. I'm studying how to do socket programming in Python because I'm working on a VTubing application for myself, and I'm planning on adding more features to it, stuff like body tracking and being able to control it from an external application, stuff like that. And all of these apps are going to be running on like different systems, not on this system that I'm streaming from. So I'm gonna need to use networking to send messages from those apps into this app on this system. So yeah, I've been learning about socket programming in Python. Later on, I'm probably gonna practice a bit of socket programming in C# as well. I kind of need to refresh my knowledge of socket programming in Python, but I need to. Thank you for the follow. I appreciate it. And on the bright side, that also tested out the Twitch alerts. Yeah, I mostly just do chill coding streams and study streams and stuff like that. It's basically just whatever I'm working on. But yeah, how are you doing? What are you up to today? So I was saying I need to do research on how much data I'm able to send in one request, in one socket request. You know, I can Google it right now. I can probably just Google it right now. Actually, I should probably also end the communication with this socket so that this thing stops listening for Okay, there it is. It stopped. Okay, so um what should I Google? Socket socket programming send limit. For TCP sockets, the maximum length you can specify is 1 GB. For UDP or RAW sockets, the maximum length you can specify is the smaller of the following values. Is the smaller of the following values? 65,527 bytes. That's basically the max of a 32-bit int, or 32,767 bytes for a raw socket. The send buffer size. So why am I only receiving maximum data size that can be sent and received? Yeah, why am I only receive? You know what? Let's try to make this buffer bigger. So let's do what did I plan? 16,000. Actually, let's go big. Yeah, let's make it like a 32-bit kind of, a 32-bit int kind of thing. Is it 32-bit? I think not 32-bit. It's a 16-bit int. I think it's a 16-bit int. Right, because a byte is 8 bits. That only goes up to 255. You make it 16 bits. That goes up to 65,535. Okay, so let's do 65,535 here. It should be 65,536 in total. But because we start counting from 0, so we go, 65,535. Okay, so I'm willing to accept this much data, right? Now let's see what happens here when I try to send that much data in. So I'm gonna send, okay, I'm gonna send 8, oh wait, I accidentally sent a quit message. Okay, so I'm gonna send in 8,000 bytes. It's sent. Okay. 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 My day is going well. I'm just learning Python. I'm a data science student. That is interesting. That is interesting. I've been looking a bit into data science myself, more specifically data analytics, and a lot of like machine learning related stuff. It's pretty interesting. I actually got into the data analytics side once I started getting into machine learning, and that's when I found out that I was kind of interesting. I was kind of interested in what kinds of patterns you can find in data. I have to go, but I will follow you more often. Thank you. I appreciate it, and I hope you have a nice day. I'll see you later. Right, so we are only receiving 7,300 bytes. Why am I only receiving? So at certain points it. Okay, what if I try to send 5,000 bytes? What do I receive? 5,000. Okay. Let's try to send that again and again and again. Okay, the output got truncated. Can I just open this up elsewhere and it'll keep updating? Okay, good, it keeps updating. Okay, socket only receiving 7,300 bytes. Yeah, this is kind of interesting to it's kind of an interesting thing to run into. Wait, did I open that? I don't think I opened that. Oh, I did open it. Okay. Okay, maybe I should be more specific with my query. So Python socket 7,300 bytes. Understanding how Python sockets are used to send large data. Yeah, I want to do that. It's not a peculiarity of Python sockets. It's actually how TCP sockets behave. When you call a low-level function like send with TCP, it may or may not send every single byte you request it to be sent, and you have to check its return value in order to. Oh wait, what is a return value I was getting? I'm getting 5,000. Oh, you know what? That's a good point. Is the thing still running? I think it's still running, right? Oh yeah, it's still running. So let's do 9,000. And that only, well, that's sending 9,000, but we're only receiving 7,300. Actually, something I could do, a Python socket not receiving all data. Yeah. Use this code to receive the data. This should work. I cannot be more specific since I don't have the context of it. Okay, I'm looking for an explanation. TCP/IP is a stream-based protocol, not a message-based protocol. There's no guarantee that every single send call by one peer results in a single receive called by the other peer receiving the exact same data sent. I thought that was the point of TCP/IP. Yeah, I thought that was the point, the fact that it gives you a guarantee. It might receive the data piecemeal, split across multiple receive calls due to packet fragmentation. You need to define your own message-based protocol on top of TCP in order to differentiate message boundaries. Then to read a message, you continue to call receive until you read an entire message or an error occurs. One simple way of sending a message is to prefix each message with its length. That makes sense, yeah. Then read a message. Then to read a message, you first read the length, then you read that many bytes. Okay, yeah, that's a fair way to do it. Buffer size 4096. It continues to receive. Data plus equals so and so. If length is less than the buffer, then break. Okay, so basically what this person has suggested here is creating a while loop and having a data buffer. It's a byte buffer, and each time I call receive, it's basically what I was talking about before, like breaking up the data into chunks. That's what this person is doing. They break it up into 4 KB chunks, and each chunk that you receive, each 4 KB chunk that you receive, you keep adding it onto the buffer as you receive more and more. So you're basically receiving pieces of the data, and the last piece that you receive, it's probably going to be smaller than 4096, which is 4 KB. So the last piece that you receive, if you receive a piece that is smaller than 4 KB, that way you know that's your last piece. So then you're basically constructing your entire data buffer that way. This is still not answering my question as to sending large amounts of data, because I know there is a limit. I remember reading somewhere that there is a limit. In total, it might be able to send like a massive amount, but like your program is not the only thing that's using the socket, or your program is not the only thing that's using the resources that are required to send and receive data. The computer has like hundreds of other things that are probably using those resources as well. So like that massive limit that you know about, it's probably divided amongst all of these things. So what portion of that division do I get, or what portion of those resources do I get? Socket max receive, socket max buffer size. Let's look at that. How large should my receive buffer be when calling so and so? I should probably ask. I should probably ask Bard as well. Bard might give me a good response. The answers to these questions vary depending on whether you are using a stream socket or a datagram socket. Within TCP/IP, the former corresponds to TCP and the latter to UDP. Makes sense. How do you know how big to make the buffer pass to receive? For stream, it doesn't really matter too much. If your protocol is a transactional and interactive one, just pick a size that can hold the largest individual message command you would reasonably accept. 3000 is likely fine. If your protocol is transferring bulk data, then larger buffers can be more efficient. A good rule of thumb is around the same size as a kernel receive buffer as the kernel receive buffer size of the socket, often something around 256 KB. Okay, but I'm not able to get anywhere near that. Okay, for a UDP socket, use a buffer large enough to hold the biggest packet that your application level protocol ever sends. If you're using UDP, then in general your application level protocol shouldn't be sending packets larger than about 1400 bytes, because they'll certainly need to be fragmented and reassembled. Okay. Right, so if I'm gonna be, how do I do this? So one way that I could go about this is I could limit everything to a 4 KB chunk, which I highly doubt that any of the messages that I'm going to be sending are going to be 4 KB, unless I'm actually like sending over a file, like an image or video frames or stuff like that. Then sure, maybe, and then I'm going to
Download
need to
meditation
come
videos.
up with a way
You'll
to
want to
break.
use it. Try YouTube Premium on us.
Yeah, then I'm going to need to come up with a way to break up the image into multiple segments and send the data that way. Or, well, break up the file into multiple chunks and send the data that way. Okay. Okay, so I'm gonna have to keep it. Okay, so let's say Python socket not sending 8192 bytes. Uh, Socket send fails to send large amounts of data. This seems to be, this is being reported in Python. Okay. Let's, wait, status closed. It's not a bug. Okay. What does the receive and send method say about f for best match with hardware and network realities? The value of buffer size should be relatively small, power of 2. Oh, so this might be a Python thing. Okay, so for this person, it's throwing an exception. For me, it's not throwing an exception. It's just, uh, give me a second, guys. I'm doing some Googling. Continuous receiving and sending. Okay. Okay. Let's open up all of these. Okay, okay.
هل بدأت ممارسة؟
Okay, yeah, sorry about that. Um, okay, yeah. So, that's gonna be it for today. I wish I could go a little longer. I'm gonna carry on doing this research off stream, but I need to end the stream right now. Guys, thanks a lot for hanging out. I hope you guys had a good time here. I'll try to stream more often. Definitely want to stream more often. And my schedule has also kind of gotten back to that point where I can now stream at night. So I'm going to carry on reading this. There was also something else that I was reading prior to, a couple of hours prior to starting streaming, that was actually one of the reasons why I got distracted in the first place. So I'm going to carry on reading up on both of these. But we made some good progress today, so I'm happy about that. But yeah, that's going to be it for today. I hope you guys have a nice day, and I will see you all next time. Peace.